For this week, we will be going over Chapter 4, which is Introduction to Probability. Now, what is probability? Probability is something that we deal every single day, from the moment that we wake up until the moment that we fall asleep. All our daily activities are based on probability. For example, if we see raining outside, we say the probability of rain outside today is 100%. If we see that it is sunny outside, the probability of rain at this current time is 0%. So probability is basically whether a particular event will occur. It is usually a range between 0 and 1. It is based on a rate, 0 meaning 0%, 1 meaning 100%. So the probability is always expressed in a percentage. 0 means it will never occur, whether 1 means the event will occur 100%. Anything in between means, not means, but means uncertainty. Now, all our probabilities are based on the experiment. An experiment is basically the process that produces outcomes. For example, flipping a coin. If we flip a coin once, we automatically know there's a 50-50% chance of either getting heads or tails. However, if the experiment involves 2 flips of the coin, the experimental outcomes are we will get heads on the first flip and heads on the second flip. We could get heads on the first flip, which is what the H stands for over here, and tail on the second flip, tail on the first flip, head on the second flip, tails on the first flip, and tails on the second flip as well. Now, the collection of these all of possible experimental outcomes, which mean that every single one of these, heads, tails, tail, heads, tail, tails, these are experimental outcomes. These are all the outcomes that can occur from 2 flips of the coin. So these experimental outcomes from 2 flips of the coin are called sample space. Now, if you look at example 4.1 on page 141 of your book, you see that it tells you how to define a sample space. And a sample space was, again, the collection of possible experimental outcomes. Now, for example, Five Guys hamburgers, which I'm assuming that everybody knows, the restaurant Five Guys. The sales manager for the Five Guys hamburger chain is interested in analyzing the sales of its 3 best-selling hamburgers. Now, as part of the analysis, he might be interested in determining the sample space, all the different possible outcomes that could occur, for 2 randomly selected customers. To do this, he can use the following steps. The very first step is to define the experiment. Now, the experiment obviously is a sale. We're observing 2 customers that will be coming in to look to buy burgers. Now, based on that, we know that there's 3 different hamburgers or 3 different burgers that Five Guys wants to take a look at. 3 best-selling hamburgers they want to take a look at. Now, the item of interest is the product sold, which is based on the defining the experiment. The second step is defining the outcome of one trial of the experiment. So what would be the outcome based on one trial? Now, based on one trial, we have E1, which is experiment 1, experiment 2, and experiment 3. There are 3 hamburgers. This is the product line. E1 would be equal to hamburger, E2 would be equal to cheeseburger, and E3 would be a bacon burger. Now, the third step would be defining the sample space. Now, the sample space for an experiment involving only one single sale, meaning only one time would the customers go in the store, the sample space would include experiment 1, experiment 2, and experiment 3, which is the hamburger, cheeseburger, or bacon burger. But if the experiment is expanded to include 2 sales, not one sale, 2 sales, then the sample space would be E1 through E9. And in front of you, you will see the actual outcome over here, sale 1 and sale 2. Now, the way that you read this table is the first experiment, there's 2 people that go in the restaurant, 5 guys. If the first person picks a hamburger, the second person can pick a hamburger as well. If the first person, the experiment 2, the second time, if the first person picks a hamburger, the second person can pick a cheeseburger. If the first person picks a hamburger, the second person can pick a bacon burger. Now, if the first person chooses a cheeseburger, the second person could either choose a hamburger, a cheeseburger, or a bacon burger. And if the first person chooses a bacon burger, the second person can either choose a hamburger, a cheeseburger, or a bacon burger. Now that would be the sample space, and that would be something that is used in an experiment. Now we also have mutually exclusive events. Now if you turn to page 144 of the book, you will see mutually exclusive events and the KPMG accounting firm example. Now if you look at the KPMG accounting firm example, you look that they're looking at outcomes of auditing. There's 2 different audits, 3 different audits that you could have on time, you could have early, and you could have late. Now, the possible outcomes for 2 audits are, if you look over in the book, you see E1 can either be audited. The first audit could be early. The second audit could also be early. If the first audit is early, the second audit could be on time. If the first audit is early, the second audit could be late. But if the first audit could be on time, the second audit could be early, on time, or late. If the first audit is late, the second audit could be early, on time, or late as well. Now, mutually exclusive, but basically if one event, before we go into that, if one event occurs, the other one cannot occur. So E1 and E2 in this particular case are mutually exclusive. And mutually exclusive events are 2 events that occur, or if the occurrence of one event precludes the occurrence of the other event. So if E1 occurs, E2 cannot occur. If E2 occurs, E1 cannot occur. That is, that at least one audit is late, then it is not possible for neither audit to be late. As far as classical probability assessment, and this is basically turning something into probability. It is basically the method of determining probability based on the ratio of the number of ways an outcome or event of interest can occur when individuals' outcomes are equally likely. For example, the probability of E1, which is probability of an event E1 occurring. For example, if we decided to flip a coin, what is the probability that we would land on heads? Heads would be one way. All the possible outcomes, or all the possible solutions, or ways that all the ways that we could do is 2 ways. So it'd be 1 over 2, which is 0.50, which is also read as 50%. So the probability of us landing in heads would be 50%. So basically the probability of an event occurring, or EI or E1, is the number of ways E1 can occur divided by the total number of possible outcomes. For example, if we look at this right here, how many times can we choose? How many times do both people? What is the probability that both people can actually, both sales can actually choose a hamburger? And we see hamburger, hamburger. Do we see more than one hamburger? Nope. So the possibility of both of them choosing hamburger is 1 over 9. And 1 divided by 9, you take your calculator and you look, the possibility that both individuals will choose hamburger is 11%. What is the possibility of at least of both people choosing cheeseburger? That new obviously would be 1 over 9. What is the possibility of choosing a bacon burger? At least a bacon burger, both bacon burgers, that would be 1 over 9. So that's the way that you look at it. All right, and then you look at example 4.5, which is on page 146, which is basically the classical probability assessment. And what they did here is this company, which is an active sporting good, the managers of the Active Sporting Goods, they planned on holding a special promotion over Labor Day weekend, and each customer making a purchase exceeding $100 would qualify to select an employee from a large drum. At the beginning of the weekend, there were 500 coupons. 400 of these were 10% discount, 50 were 20%, 45 were 30%, and 5 were 50%. Now, what is the probability of getting a particular discount amount can be determined using classical assessment with the following steps. So obviously the very first step is defining the experiment. So the experiment in our case is an envelope that is selected from a large drum. The second step is determining whether the possible outcomes are equally likely. And because you have an equal chance of selecting either one of the envelopes, you can pick any one of the envelopes, then we do have an equal chance of choosing. The outcomes are equally likely of choosing an envelope. The probability is the same of choosing any envelope. Now, determining the total number of outcomes would be step 3. So there are 500 envelopes in this particular drum. So that is the total number of outcomes. Now, defining the event of interest, we might be interested in assessing the probability that the first customer will get a 20% discount. So now we know that the probability is equally likely to select any envelope, but what if we say that one customer, what is the probability of the first customer choosing the 20% envelope? Now we look back at the directions and we say how many envelopes had the 20% discount, and we say 50 were with a 20% envelope. Now how many coupons or how many envelopes were in that drum? There's 500 coupons or envelopes in that particular drum. So when we skip step 4, we go to step 5, and we say that there are 50 coupons with a discount of 20%. And then step 6 would basically be figuring out what is the percentage or what is the rate that we would be able to select the 20% envelope. And it would be a number of ways 20% can occur, which is 50 divided by 500, which is 0.10, which is in other ways said as 10% discount. Then we also have the relative frequency assessment, which is the number of times that E1 occurs divided by the number of trials. For example, 4.6. And example 4.6 is basically if you look at people, the Starbucks actually wanted to see how many people drank caffeinated and decaffeinated tea. So they looked at step 1, which is defining the experiment, which is a randomly chosen customer selects between decaf and caffeinated. The step 2 would be defining the events of interest, which is the manager is interested in the event E1 customer selected caffeinated. Step 3 would be the correct or the manager, what is the number of occurrences that can occur, which is 2,250 sales and of decaf and caffeinated. So N would be 2,250, and then for the event of interest is determining the number of occurrences. So 1,570 sales were for caffeinated drinks. So if I wanted to determine the probability assessment, I would say the probability of E1 is the number of times E1 occurs divided by N, which is 1,570 divided by 2,250, which is 0.6978, which is 69.78% chance or 70% chance of a person purchasing a caffeinated drink rather than a decaffeinated drink.